So today we're going to be learning about proportions, ratios, and direct variation. This is kind of a continuation of what we just learned in class. So our essential questions of today are, what is direct variation and how do I solve those types of problems? The other one is, what are proportions and ratios and how do I solve those types of problems? Bet you guessed it, we're learning about proportions and ratios and what they are and how to solve those types of problems. So the first one is a ratio. And ratio are relationships between two numbers. Sometimes they're expressed as A to B, or A colon B, or A over B. Proportions so equations that show that our two ratios are equivalent. Those are proportions. So let's look at some of the steps of solving these proportions, ratios, and direct variation. First, we are going to define your variables. Next, we're going to write an equation. Third, we're going to solve the equation. And last, we're going to answer the question or questions that are being asked by the problem. Seems pretty easy. So this last one is direct variation. So a linear relationship is a direct variation if y equals k times x, where k is the constant variation. So let's look at some examples. So it says, use the table below to answer the following questions. If x equals the number of computers and y equals the number of students, write an equation that could be used to determine k, the number of students per computer. So we have x is computers and y is the number of students. So now I'm looking for an equation where k is the number of students, which is y, per computer. So that means over x. So that's my equation. So this, with numbers, can be k equals 10 over 3. Can also be k equals 20 over 6. You can also write it as k equals 30 over 9. And where I'm getting these numbers is from right here. 10 students per 3 computers. We have 20 students per 6 computers. 30 students for 9 computers, and so on and so forth. So in part B says, if there are 1,250 students in the school, how many computers will be needed to meet this projected ratio? So I'm going to write my ratio again. 10 over 3. And that's going to equal the number of students, which is 1,250. And I'm looking for the number of computers, which is x. Now all I need to do to solve this is cross multiply and divide. So cross multiply and divide. So I'm going to do 3 times 1,250 and then x times 10. So I got 10x equals 3,750. Now my last step to do is divide by 10, because I'm looking for x. So that gives me x equals 375. So that's my answer. So I would need 375 computers if there are 1,250 students in the school. Let's look at example number 2. So on a map, if I have 1.5 centimeters represents 60 kilometers, what distance does 6 centimeters represent? So I'm going to go ahead and set up my ratio. I'm 1.5 or 1.5 centimeters represents 60 kilometers. Okay. If I have 6 centimeters, I'm looking for how many kilometers it have. So I'm setting up my proportion here. Again, all I'm going to do is cross multiply and divide. So I'm going to do 1.5 times x and 6 times 60. So I get 1.5x equals 360. My next step is going to divide by 1.5 because I'm looking for x. And I get x equals 240. So that means 6 centimeters represents 240 kilometers. And that would be my answer. So go ahead and write your questions and summary for this short little lesson.